Today we're doing the largest 12 volt and 48 volt RV air conditioner comparison ever done on YouTube. So 6 different RV AC systems, 4 12 volt systems, and 2 48 volt systems. And instead of relying on manufacturer specs or marketing claims, we're gonna test them ourselves. Every system here today is gonna be tested under the same outdoor conditions while measuring airflow, temperature drop, power usage, efficiency, and actual cooling performance. Every unit will use the same duct setup, the same testing equipment, and the same environmental conditions. So by the end of this video, we're going to find out which RV AC system actually performs the best. Now before we get started, let's quickly talk about the battery systems powering these AC units. For the 4 12 volt AC systems, I'll be using 2 Renogy Pro S1 240 amp hour semi-solid state lithium batteries. The 12 volt AC units will all be tested using the same Renogy battery setup, so the battery conditions and power delivery remain as consistent as possible between tests. 2 of the AC units will be tested on one battery, and the other 2 will be tested on the second battery, although obviously not at the same time. These batteries are designed specifically for demanding RV and off-grid applications and include features like Bluetooth monitoring, integrated self-heating, and a smart BMS system. Each Renogy battery is capable of up to 240 amps of continuous discharge current, which is important because several of these 12 volt AC systems can pull very high amperage under load. And for the 2 48 volt AC systems, I'll be using this LiTime 48 volt 100 amp hour lithium battery. Both 48 volt AC units will use the same battery setup, so the power delivery conditions remain as consistent as possible between the 2 systems. This battery stores just over 5 kilowatt hours of energy, which is a substantial amount of onboard power for RV and off-grid applications, and it includes Bluetooth monitoring and an integrated smart BMS. The LiTime battery is capable of up to 100 amps of continuous discharge current and is specifically designed for higher power 48 volt applications. Now, one of the reasons I wanted to include both 12 volt and 48 volt systems in today's comparison is because I think we're starting to see a major shift in RV power architecture. As RV power demands continue increasing, especially with air conditioning, higher voltage systems are becoming more and more interesting because they dramatically reduce current draw compared to traditional 12 volt systems. And today's testing should give us a really good look at how those different voltage architectures compare in real world performance. First up is the Velit 48 volt rooftop AC system. This unit is rated at 11,000 BTU and includes app control along with multiple cooling modes including sleep, eco, normal, and turbo, along with a separate fan-only mode. One of the things that makes this unit interesting is that it's designed around a true native 48 volt architecture instead of relying on a traditional inverter-powered setup. So this system will be powered directly from the LiTime 48 volt battery. Now I'm really curious to see how the lower current draw of the 48 volt systems compares against the larger amperage we'll likely see from some of the 12 volt units. Next is the 48 volt version of the OutEquip Pro. So this unit is rated at 11,000 BTU cooling and does not include a heating mode. It features normal, cool, eco, turbo, and fan modes along with integrated lighting and an LED display that can be turned off. Like the Velit system, this AC will run directly from the LiTime 48 volt battery. One thing that immediately stands out about this unit is just how physically small and compact it is compared to many traditional rooftop RV AC systems. In fact, both of the OutEquip Pro systems in today's comparison are among the smallest rooftop AC units I've personally tested. And despite the smaller overall size, they still claim very competitive cooling performance. So I'm really interested to see how this compact 48 volt system performs once we start collecting real airflow and cooling data. Now moving over to the 12-volt systems, next is the OutEquip Pro 12-volt AC. This unit is rated at 10,000 BTU cooling and includes the same feature set as the 48-volt version. It features normal, cool, eco, turbo, and fan modes, along with integrated lighting and an LED display that can be turned off. Like the 48-volt version, this unit is also extremely compact physically compared to many traditional rooftop AC systems. And honestly, both OutEquip Pro systems are among the smallest rooftop AC units I've tested so far. The only other unit in today's comparison that's really close in overall physical size is the ZenGem system. This system will be powered using the Renogy semi-solid state battery setup. And one thing I'll really be watching during testing is how this compact design balances power draw versus actual cooling performance. Next up is the CountryMod 12-volt system. So this unit is rated at 10,000 BTU cooling and includes normal, cool, turbo, eco, sleep, and fan-only modes. It also advertises a heating mode, although I won't be testing that today during this comparison because the outdoor temperatures are simply too warm right now for meaningful heat testing. The system also includes the ability to shut off the LED display lighting at night along with motorized swivel vents. One thing that makes this unit a little different from several of the others in today's comparison is that the power wiring is not permanently attached, so the power cord actually needs to be connected during installation. This system will also be powered using the Renogy battery setup. And honestly, I'm really curious to see how this unit performs once we start measuring airflow, sensible BTU, and efficiency because on paper it looks very competitive. Next up is the ZenGem 12-volt system. So this unit includes a high mode, which is essentially its turbo cooling mode, along with auto cooling, sleep mode, and a fan-only mode. It also includes integrated lighting along with motorized swing vents. And one interesting feature on this unit is that it displays both inlet and outlet air temperatures directly on the system itself, although we'll still be using external thermometers during testing so we can keep the measurements consistent across all of the AC units. Physically, this is also one of the smallest rooftop AC systems in today's comparison and is very similar in size to the OutEquip Pro systems. One thing I also noticed right away is that the power wires on this unit are noticeably smaller than the wiring used on several of the other 12-volt systems in today's comparison. So it'll be interesting to see whether those wires start heating up after running in high mode for an extended period of time. This is probably one of the wildcard systems in the entire test because there's not nearly as much real-world testing available on this unit compared to some of the others we're looking at today. Like the other 12-volt systems, this unit will also run from the Renogy semi-solid state battery setup. And finally, we have the Mod's Pioneer 12-volt system. So this unit is rated at 11,000 BTU and includes turbo, eco, sleep, and fan modes. It also includes integrated lighting, motorized swing vents, a voltage display function accessible from the remote, and the ability to shut off the LED display lighting. One thing that immediately stands out about this unit is that it's physically wider than many of the other rooftop AC systems in today's comparison. And the reason for that is because this is what Mod's Pioneer calls a dual cool system. So instead of using a single exterior cooling fan like most of the other units in today's test, this system uses two exterior fans to exhaust heat from the AC system. So it'll be really interesting to see whether that larger dual fan design translates into measurable cooling or airflow advantages once we start testing. Now, before we start testing, I want to explain exactly how this comparison is being done. All 6 AC systems are being tested outside under the same environmental conditions and running at approximately the same time. Now, that's important because every system is being exposed to the same outdoor temperatures, humidity, and environmental conditions. And the goal here is not to test one specific RV installation. The goal is to isolate the actual performance of each AC system under the same exact conditions. Every AC unit will use this exact same cardboard duct system that I built specifically for this comparison. And the reason that matters is because I want the duct size and airflow restrictions to remain identical between every single AC system. The only difference in airflow should be the actual performance of the AC itself. To measure airflow, I'll be using this airflow meter and taking measurements at 4 separate locations across the square duct opening. I'll then average those readings together and calculate the actual CFM output for each AC system. I'll also be measuring both the inlet air temperature and outlet air temperature for every unit. And from the airflow and temperature measurements, we'll calculate sensible BTU output, EER efficiency, and cost per BTUH. For power measurements, I'll be using a Victron shunt installed directly between the battery and the AC system. That's going to allow us to measure the actual watts used, amps used, and operating voltage for every AC unit in today's comparison. All right, so let's get started. So I'm going to turn the vlet on, and I'm going to give it about 15 minutes to level out before I start taking measurements. Now that all of the testing is complete, let's take a look at the results. One of the first things that immediately stood out during testing is just how close several of these systems actually performed once we started measuring real airflow and real cooling output. Even though several of these AC systems are physically very different from each other, the measured sensible BTU numbers ended up being surprisingly close in a lot of cases. For example, both the vlet 48 volt and the OutEquip Pro 12 volt systems produced right around 7,500 BTUH during testing, despite having very different physical designs and power architectures. The ZenJum system also landed surprisingly close to the OutEquip Pro systems in measured cooling output, especially considering how compact the unit physically is. But one of the systems that really stood out during testing was the Country Mod. The Country Mod produced the highest measured sensible BTU output in the entire comparison at just over 9,000 BTUH, while also producing the highest calculated EER efficiency rating. And honestly, that result was a little surprising considering some of the other systems were physically larger or advertised similar cooling capacities on paper. The Mod's Pioneer also performed very well during testing. Its larger dual fan design appeared to move a substantial amount of airflow, and the measured BTUH output ended up being one of the stronger results in the comparison. And visually, you can definitely see how much wider that system is compared to many of the other rooftop AC units in today's test. One of the more interesting things from today's testing was comparing the native 48 volt systems against the 12 volt systems. The 48 volt systems generally operated at significantly lower amperage while still producing very competitive cooling performance. So I think that's one of the biggest takeaways from this entire comparison. As RV power systems continue evolving, higher voltage architectures are becoming more and more interesting for off-grid applications because they can reduce current draw significantly while still delivering strong cooling performance. So overall, the final rankings ended up being much closer than I expected going into this comparison. Now, before we wrap up the video, I do want to point out that this comparison wasn't based on just a single number, because at the end of the day, choosing the best RV AC system really depends on what matters most to you. Some people may care most about maximum cooling, efficiency, compact size, lower current draw, features, or overall value. So instead of focusing on only one category, I ranked these systems based on a combination of sensible BTU output, EER efficiency, cost per BTUH, physical size, features, and overall performance. Based on today's testing, this is how the systems ranked overall. Ranking number 1 is Country Mod 12 volt. Number 2, Mods Pioneer 12 volt. Number 3, OutEquip Pro 48 volt. Number 4, VLIT 48 volt. Number 5, OutEquip Pro 12 volt. And number 6, Zenjum 12 volt. Overall, I think the biggest takeaway from this comparison is that manufacturer BTU ratings only tell part of the story. Because once you start measuring actual airflow, actual temperature drop, actual power usage, and actual efficiency, the real-world performance differences become much more obvious. And honestly, several of these systems performed much closer to each other than I originally expected. So if you enjoy this comparison and want to see more real-world RV and off-grid testing like this, make sure you hit that like button and subscribe. And if there's another AC system you'd like to see added to the next comparison, let me know down in the comments below. Thanks again for watching, and remember, stay cool!